So it's lesson 1, part 2 of server-side scripting, fall 2021, in our Lakehead section. So we've answered some basic questions about .NET in our whiteboard. So make that visible. So I've got just a short slide deck here, going to fill in a little bit more about the history and background of .NET so you understand the evolution and kind of where it fits. This file is here for you on D2L, the lesson 1 slides. It's not very long. So .NET, ASP.NET, it's a mature technology. It was actually created back in 2002. I purchased the first version of Visual Studio.NET back then for the low price of, I think it was $1,700 US at the time to get a copy of Visual Studio Professional. So I've been working with .NET for a long time, and before that, the word, where does ASP come from? Before that, Microsoft's web framework was called ASP, Active Server Pages, and it used, the code was written in VB script, so a form of Visual Basic, and it was interpreted in much the same way that PHP is now. So we used ASP for a while. When I first started as a web developer, ASP was the technology I was using even before .NET came around. And then in 2002, Microsoft decided, hey, we're going to overhaul the way our web technology works. And some of the big things that they offered that really weren't common back then, one, as Christopher mentioned, was the ability to write compiled code. So it's faster and it's more secure than interpreted code. It also allowed us to use object-oriented programming in a web environment, which again wasn't something that many web development frameworks offered back at the time. It also allowed a single code base, so we could write back-end code in C# and then deploy either a Windows Form front end or a web front end that sat on top. So the original version, and I think Megan, this was what you were talking about, the original version was called Web Forms, and I actually still maintain a couple of really old Web Forms projects that either other developers created and I've taken over the maintenance of, or even a few that I built a long time ago. So MVC was not part of ASP.NET until 2008. They adopted it. And then .NET Core was added 5 years ago, where they made the stack open source and cross-platform. So I'll just show you briefly a really old Web Forms application. So this is the admin panel. This site's like 15 years old. I still manage it, but it works, so the client has never wanted us to rebuild it. So here's the login screen. Just kind of looks like a simple login. You'll notice it's got the ASPX extension. So probably some of you have seen that file extension before. When you see .aspx, that means it's a Web Forms. It's a really old ASP.NET project. And they still are out there. So here's what the code looks like. So here's our login.aspx. It's actually got a visual form designer here. And if we look in the source, it has these kind of unusual directives. And it looks like my Visual Studio is crashing on me. Okay, so what you'll see here, and yes, we see really bad table for formatting. Like I said, it's really old. So you have this text box, and it's got this ASP text box with run at equals server. And then we have an automatic validator, and same, instead of being a regular HTML input, we see this ASP text box. So there were two parts to these files. There's the ASPX file that holds the HTML with kind of these special ASP tags. And then this file was actually, the server-side code is written in VB. So there's a file called login.aspx.vb. So it's like a twin, a matched file that contains all of the server-side code. So all the server-side code in Web Forms, it was separated out from the HTML, which if you think about how we built our PHP pages, all this stuff is together, right? All the logic and all the server-side logic and all the front-end HTML code, it's all jammed together in one file. So this was one of the other nice things when Web Forms came out in 2002. It would separate out So here was the server-side code to process, to try and validate a user, and then decide what to do. Do we redirect the user? Do we set a cookie, whatever? So we had this nice separation of the front-end code from the back-end code. This is the original version of .NET, okay, from way back in 2002. Now, this code also is messy and not nearly as fast as it needed to be, and that was partly why Microsoft moved to MVC in 2008. They've dropped support as of 2018 for web forms, and then they moved to .NET Core in 2016. By and large, we see a lot of .NET in medium and large organizations, so things like government, big corporations, but we can still use .NET for small-scale application development as well. So we talked about code compilation. We've touched on that a few times. We can use Visual Studio, which has tons of plugins and libraries to make our lives easier. It also automates a lot of things. So this was one of the other primary goals of the .NET project. Microsoft looked at what are all the mundane, repetitive tasks that web developers waste a lot of time doing, and can we add these things into Visual Studio to save developers time? So we can get a working site up and running almost instantly with Visual Studio. We've got the benefits of the MVC pattern. We'll talk a little more about these. And then we talked a little bit already about some of the integration. So things like SQL Server, Azure Cloud, and of course, GitHub version control, which is made even simpler now that, as of a couple years ago, now that Microsoft owns GitHub. Get this really robust security model. So all kinds of libraries and plugins. So later in the course, when we do things like add Google sign-in or Microsoft sign-in, well, there's already a library available. We can just basically plug it in and configure it. We don't have to write a whole bunch of code or copy and paste a whole bunch of code into our app to get it to work. You guys are already familiar with Visual Studio. One of the cool things Visual Studio offers for web development, which never really existed before .NET, is runtime debugging. So you probably use the runtime debugger in your C# course, where you can put a breakpoint in your code, just like in your Java applications as well. You can run your app and then watch the code execute at runtime. Well, ASP.NET was the first, and it's still one of the only web frameworks that allows us to do this. So we can put breakpoints in our server-side code, load a page in our browser, and then watch the server-side code execute one line at a time to track it and see what happens. There's all sorts of project templates. So when we want to build an MVC application in Visual Studio, we can start with an empty solution, or we can let Visual Studio give us a working boilerplate site, which we can then modify. And that's what we're going to do. There's also templates for building REST APIs, which we'll do later, or building web applications with an AngularJS or React.js front end. A little bit beyond the scope of our course, but they're there. It gives us automatically, when we create a new project, our project is automatically going to include useful tools like Bootstrap and jQuery. If we don't want those things, we can get rid of them. If we want them, but we want to customize them, we can do that. We've got all kinds of built-in security features, like pre-built register and login pages, multi-factor authentication, hooks for social authentication. We have this package manager called NuGet. Anybody work with NuGet before or know what a package manager is or what it does? Okay, Sam, you've used Node package manager. So, well, Node is older. NuGet sort of modeled on Node. What's the purpose of Node package manager? Yeah, it's for installing dependencies. So we want to add functionality to our project. We can go and search for an existing code library that already includes that functionality, so we don't have to spend time writing and testing that code. We can just plug it into the project and use it. Okay, and we will do that several times during the course. We've got really robust tools for doing unit testing, which we'll do, and great version control integration with things like Git, and GitHub. So tons of reasons to use Visual Studio and ASP.NET. So I've been building ASP.NET applications for 2 decades now. It's still my web technology of choice. If I have a new customer and I'm going to build a brand new web application, if I have the choice of technology stack, I'm almost always going to choose ASP.NET. So before we open up Visual Studio and start playing around with ASP.NET, which we're going to do soon, I want to look a little bit more at how MVC works, particularly in relation to the different files and components and how the URL routing works. So in ASP.NET MVC, the naming conventions for things are really important. The framework will automatically do a lot of stuff for us, but it wants us to follow a certain set of rules in terms of how things are named and where files are located. Okay, so take a look at this URL, this sample URL. I'll throw it in the chat as well, but you can see it on my screen under the MVC diagram. If you look at this URL, domain/order/details/1000, that's a pretty descriptive web address, right? It gives you a pretty good indication of what's going to happen on that page. So what would you expect would happen at this URL? Should be fairly self-explanatory. What would you expect to see at that page? Adil, you got it exactly. So that page is going to query the database. There's probably an orders table, and it's going to fetch the record with ID. Maybe it's not exactly the 1000th order, but it would be the record with the primary key, the ID value of 1000, right? So it's going to show us one order on the page. So ASP.NET is going to parse this URL, this dispatcher, and it's going to, the URL is basically a set of instructions as to what the application is supposed to do when it gets this request. So the first part of the URL after so here's our root domain, our base domain. The first part after the slash is indicating which controller in the application, which logic file is going to process the request. So in this case, we're going to have a file called the orders controller, and it's going to live in the controllers folder. So the first subpart of our URL is the controller. And we may have many controllers. Typically, we'll have a separate controller in our application for every table in the database. We have 15 tables in SQL Server. We're going to have 15 controllers in our MVC app. And then the next part of our URL indicates the method or the action that gets invoked inside of this controller. So our orders controller file is going to have a method called details. And the last part of the URL, which is optional, is going to be any parameter value. So the dispatcher takes this URL, it sends the request to our orders controller, it executes the details method, and it sends in a value of 1000. Now, Adil was right in saying the ultimate result of this is in the user's browser, they're going to see the details of order number 1000. So let's kind of break this down, what happens. So this request comes into the orders controller. It calls the details method and passes in 1000. So how does the controller process it? What does it do with this instruction? It queries the database using an order class, an order model. And this model will look very similar to the kinds of classes you will have created in your Java class with Jarrett in your Intro to Objects course. So there'll be a models folder, and in here there'll be an order class. That class will connect to the database. It'll pass in ID 1000, and it will fetch back the details of that order and hand that object back to the controller. So the controller uses the model to interact with the database. And then the last step is the controller has to render a view in the browser. And that view is going to be in the views folder. In the orders subfolder, there's going to be a view called details that has this extension, CS_HTML. And not only is the controller going to load the view, but it's also going to pass it the order object 1000 so the user can see the details of that order. So we've got this very sort of well-structured, well-segregated application. So why would we do this? What are some of the benefits to using this kind of pattern where we've divided the models, views, and controllers? This offers a number of benefits. How do you think this might be useful? Okay, sorry, I'm Megan. I'll just answer your question. The controller is just assumed. So it doesn't need to be included. The URL is friendlier without the word controller in every URL. So this is the naming convention in ASP.NET. It may be different in other MVC frameworks. So in ASP.NET, we automatically add the word controller to the suffix of each controller file, but we don't need to include it in the URL pattern. It's a very good question. So why do this? If you think back to like how we built files in our PHP class, how is this different and what would some of the benefits to using this architecture pattern be? Okay, Sam, that's a great reason. Yeah, support for different teams. Can you expand on that a little bit more? Yeah, front end, back end team, exactly. So we say, hey, Adam's the UX guy. And Adam says, no one else can touch the views except for me. I'm going to do the work. Sam, Rich, I don't want you guys mucking about in here, right? Maybe Sam's dealing with the back end, dealing with the database. He's going to say the same. I handle the models. I will decide what they look like. Rich, Adam, you guys don't get to touch them. So it makes dividing the work easy. Yep. What other benefits does using this pattern offer? Certainly working in a team environment, dividing the work. What else does this structure offer? So we have a lot more files, but each file is going to tend to be smaller than in, let's say, the structure we used with PHP. You think of any other reasons, any other benefits that this structure offers us? Okay, yes, Adil, absolutely. Can you expand on that a little bit? Definitely it helps us optimize. Tell me a bit more. Okay, yes, definitely this is more secure. Absolutely, because we can lock down the individual components. Yeah, Adil, that's right. Because we're separating, it's called the separation of concerns, right? So things can compile more quickly. Our back-end code can compile more quickly because it's, for example, divorced from the front-end code, which is actually HTML and doesn't compile at all. That's right. It provides more organization and clearly delineates, thanks, Megan, the relationships between them. Yep. What about things like quality assurance or reusability? I would suggest that MVC is really good for both of these, for quality assurance and reusability. Can you think of why? Yeah, Adil, why does it help in debugging? It definitely makes debugging easier. Why would this structure save us maybe some time and energy when we're debugging? Exactly. If we have a problem in the UI, well, we don't have to look through all the code here. We know who's responsible and which file the problem is in, and we're not going to be confused reading through logic code or data code. That's a great answer, Adil. You've got it. What about for reusability? How is the pattern helpful if we want to? Yeah, exactly, Megan. So let's say we build an application and that application needs like an event calendar, right? We're building for a client. Let's say it's, I don't know, dentist's office or chiropractor's office, and they want event scheduling. We build it in their application. Well, then we build another application that needs event scheduling. We can borrow, you can reuse or repurpose the model and controller and just put on a different set of views. So it's easy for us to reuse or repurpose the code when it's modular like this. Or maybe we want to build a mobile app with the same logic. So we're just going to replace the set of views. You know, as a web app, we've got HTML views, but for mobile, we want Android activities or iPhone. I don't know what the term is. I don't know if iPhone uses the term activities, iPhone screens, right? But we can keep our backend logic and code. And they might even talk to the same database, but we're going to change the front end. So MVC has really, over the last decade, exploded and become sort of almost become the standard way of building many, many applications, regardless of language or platform. We're going to get used to this structure. And Visual Studio and Microsoft make it really easy so long as we follow the naming conventions that I've kind of outlined in my example on this slide. And again, these slides are on D2L for you to reference at any time. So when we think about some of the benefits of this pattern, well, we've pretty much touched on all of these already. I realize this may be new for some people and a bit unfamiliar. It's actually quite easy. And once we work with it for a few weeks, it's going to be really simple. So don't worry if this seems somewhat out there right now. It won't for very long. And we'll come back to this. Okay, so this diagram is here for you as well. I've enabled it now if you refresh your week 1 folder. So we'll probably refer back to this diagram a fair bit. So for the first few weeks, we're going to ignore the model. For the most part, we may use it a little bit, but we're mostly going to focus on the view and controller for now. So simple way to think about it, the models represent your data, the view is the presentation layer, and the controller is the logic or kind of like the messenger that acts as the interface or the bridge between our front end and our back end. The front end and back end don't speak to each other directly ever in MVC applications. Everything gets routed through the controller. All the requests and all the data and logic get processed in the controller, and the controller acts as this bridge between the view and model. So the controller is really kind of the brains of the whole operation. All right, so I'm going to suggest let's fire up Visual Studio and let's play around a little bit with this web application templating and some of the MVC structure that Visual Studio offers. So open up Visual Studio. And we want to create a new project. So you should get this splash screen. So create a new project. There's lots of project templates here. But the project template we're going to work with in this course is this one here that I've highlighted, ASP.NET Core Web App Model View Controller. And I will put it in the chat for you as well, so you know which option to pick. If you don't see it, you can scroll down. You can also, even in the search bar at the top, search for ASP.NET Core Web App. So there's a few, but we want this one. This is basically just a static website. We want this one. We're going to be working with ASP.NET Core Web App Model View Controller. And as I mentioned, you can see below the templates for things like Angular and React. So I'm going to pick this one. And I'm going to click Next. Now, this is going to be kind of a throwaway project. We're just going to play around with this one today. Next week, we'll build a project that we're going to keep. And much like in our PHP course, we'll work with that same project week after week, and we'll just keep growing and expanding it. So today is just kind of a throwaway project. So I'll just call this, I'll call it Monday 1st, because I'm not keeping this, so the name isn't really important. You can call it whatever you want. Just don't put any spaces in the name. So I don't care what you call this project. We'll click Next. And then there's a few options here we want to pay attention to. First one is the target framework. Now, in this course, we want to be using .NET 5. If you don't have .NET 5 installed today, no problem. You'll have .NET Core 3.1 or 2.1, whatever. Any version is okay for today. Is there anybody who doesn't have .NET 5? If you don't have it, I will show you where to get it, but it's not critical for today. Based on my other sections of the class, I'm assuming probably everyone has .NET 5. It comes with Visual Studio 2019. And there's a couple other options here. The authentication type defaults to none, but we're going to change that. Instead of none, we want to use individual user accounts, individual accounts. This means we can store usernames, users, in our database. And the last option, which is already checked off for me, if it's not checked for you, you can check it off, is configure for HTTPS. So we want our site to use SSL for security. We talked about it a little bit. We talked about SSL a little in our PHP class. We'll talk about it again kind of midway through the semester when we have a couple lessons focused on security. We'll talk again about SSL and why it's so important. We don't want Docker. We don't need to containerize our application. And we don't need Razor runtime compilation. So you can just leave those last two unchecked. So your options should look the same as mine. .NET 5 is the framework, individual accounts for authentication, and HTTPS enabled. When you've got all those options, you can just click the Create button down at the bottom right. Visual Studio will build your project. So I'll click Create. I'll go through this same process next week. Sam, Docker and Kubernetes are software that allows you to containerize your app. So what it allows you to do is move your application. Basically, it will let your application run on any kind of environment. So the container, if your application includes support files from outside your application, it basically lets you package up an application and all the support files, and then move it, let's say, from a Windows server to a Linux server to a Mac operating system. So it basically lets you decouple your app from an operating system. It's sort of a way of virtualizing your application, and it's become extremely popular. for making applications portable and reducing their footprint. It's a cool technology. I haven't worked with it a lot. I have a little bit. So we'll get this screen, and we go to Solution Explorer, we can see the structure of our project. So let's have a quick look at what's here. So we've got a few dependencies. So because we chose individual user accounts, we've got some packages related to security. This is these identity packages. And then we've also got libraries for connecting to SQL Server. So the data access library is called the Entity Framework. It's kind of like we use PDO in PHP. In ASP.NET, we use Entity Framework. That's a library for letting .NET talk to a data source. So we've got a few packages already configured so our app can connect to SQL Server. Properties is just some configuration if we want to launch the server. We have a www root. Our project already contains folders for CSS, JavaScript. So we actually get a default style sheet, which we can override. You know, we can make changes to the default CSS, which we will do. We already have a default, an empty JavaScript file where we can write any client-side JavaScript we need. And then under the lib folder, Visual Studio actually includes Bootstrap, jQuery validation. So we don't have to keep any of these things, but if we want them, they're already here. Again, this is a big time saver. We don't have to go and source and download and include this stuff. Create folders, it's already here. Areas is for authentication to do with user identities. We're not really going to do anything with this until later in the course. And then we've got, you can see for our next few folders, we've got controllers. So what does one of these controllers look like? Well, we've got a home controller already here. It's got a C# extension. We've got a class declaration. It inherits from the base controller class. We've got a constructor. And then we've got a couple of methods here. One called index and one called privacy. With some logic, we'll come back and dive into this a little bit later. But that's what a base controller looks like. We've got a data folder. Again, we're not going to work with this today, but we've already got a database connection class already prepped and ready to go in our template. So we'll work with this file starting in 3 weeks. Then we've got a models folder. Well, we don't have any models yet, but we'll define some models a little bit later. And then we've got some views. So we've got a home folder and a shared folder. And then a couple of other files here. We've got a JSON file for configuration values. So things like our database connection will go here. If you remember in our PHP class, I actually had to create a database file and put in a connection string. Visual Studio gives us a place to put it. And then we can put other things in here like API keys for doing like Google sign-in, mail server credentials if we want our application to be able to send email, anything, any global variables, global settings, they can go in appsettings.json. We also have a startup file, so code that runs when our app is launched. So things like connecting to SQL Server, setting up whether new users have to confirm their accounts or not, whether HTTPS is enabled, some basic configuration values. We'll play around with this more through the semester. We'll come back and look at this a bit later too, this section of the file. So we actually have kind of this pre-existing site. So how do we see it? How do we run it? I mean, we can look at it in Visual Studio, but I actually want to load it in the browser. One of the other great things about Visual Studio for web development is that it actually has a web server built right into Visual Studio. So in our PHP class, if you remember, we needed our code editor. I was using PHP Storm. Some of you are using Visual Studio Code. But we also had to install XAMPP as our web server. And every time before we could run our PHP files, we had to open up XAMPP and start the server. Visual Studio, we don't have to do that. It has a built-in server. So Microsoft's production web server is called IIS, Internet Information Server. And they've given us a light version of IIS, and it's baked right into Visual Studio. So if I want to launch the website, I can go up to my debug menu, and I'm going to choose this option. Now we have two start options. There's start debugging and start without debugging. Generally, I recommend you use start without debugging. It's actually faster and offers a few advantages. Either one will launch your app, but I recommend start without debugging. I'll show you why in a little bit. So if you click debug and start without debugging, you'll see it's going to build, it's going to compile our code. And it gives me this. Gives me a security warning. This is nothing to panic about. I'll show you why, and we can get around this. I'm going to click the advanced button, and it says our local host is using an invalid security certificate, which the browser doesn't trust because it's self-signed. So Visual Studio is creating its own SSL certificate. It's not from a recognized certificate authority like GoDaddy or VeriSign. This is fine. This is not a security risk. The browser is just being overly protective. So I'm going to click accept the risk and continue. This will allow our site to load using a self-signed SSL certificate. We're just working locally. This is completely safe. So when I click accept the risk and continue, here's what we get. We get a working website. Okay? The name of our project is here. We have a privacy page. We've got a home page. We've got a shared header and footer. Some content on our home page. We've even got links up here. So if I click register, it actually built a registration page for us. If I log in, it's built a login page. It's got a forgot password page. It's got a resend email confirmation page. When we create a new project and we pick individual user accounts, Visual Studio includes all of these things for us, and they're actually functional as well. So you can see what a huge time saver it is to use this MVC ASP.NET template to start our project. It even gives us this. I collapse my browser down. Right? It gives us the little Bootstrap jQuery mobile menu. Notice our page is mobile responsive, scales, and we get the working drop-down menu. So this is a huge time saver for us. We want to start building an app. Anybody have any questions so far? So I'm going to go back to the debug menu. I mentioned that I'm going to tell you show why I preferred the start without debugging. I could start debugging, that will work. But when I start the debugger, it locks my code. So when the debugger is active, I can't actually make changes to my project. in order to make changes to my project, I have to stop the debugger, make my changes, save them, and then start it again. So unless I'm running my code with a breakpoint to watch the code execute, which I'll do occasionally, but not regularly, then start debugging is the more efficient option. When I choose start without debugging, the server's launched and running, and we can make changes to the code without having to stop and restart the server each time. So starting debugging is going to be more efficient. So let's come back and look at how the MVC pattern works. So I'll go back to my home page. So when I click the privacy link, I click it and it loads the URL home and privacy, and we get this page displaying in the browser. So how does this actually work? What happens inside the application when we click the link and load home/privacy? What gets triggered at this URL? If you look back to that MVC diagram that's posted on D2L. Exactly. Thanks, Megan. So it takes the first part of the URL after the root domain, so the home controller, and in there it calls the method called privacy. So this was built in. So in the home controller, which is in our controllers folder, we have a method here called privacy. And what does this method do? So when we execute privacy, what happens? I know there's a bit of unfamiliar code here. We'll talk about that in a minute. Right. Thanks, Christopher. So it loads a view. So what view gets loaded? Well, if our home controller, here's where the naming conventions are important. Our home controller has a method called privacy, which means inside of our views folder, we have a home subfolder. So the name matches the controller name. And then we've got, notice we have two methods, index and privacy. We have two views, index and privacy. So this is the HTML view that gets loaded. So here's a question. We're not specifying which view to load. It just says return view. If we look at the code on line 23, it returns a view, and on line 28, we have another one that returns a view. How does the server know? How's it supposed to know which view to load? We have two different methods. The method body is identical in each one. How is it that these links seem to work? The home link loads this view. The privacy link loads a different view. How do you suppose that happens, considering lines 23 and 28 are identical? Shouldn't we have to specify in each return statement which view should be loaded specifically? Doesn't look like we have to do that. So how does this work? You got it. Good guess, Megan. You're absolutely right. So the naming convention is the method name will have a view with the exact same name. And as long as it does, it will automatically look for a view with the exact same name. So I've got one other question, again, looking at the URLs. To make this even a little more confusing, when I click privacy, it loads /home/privacy. So that seems pretty straightforward. Home controller has a method called privacy, and then views home loads the view also called privacy. So that seems to follow our pattern in our naming convention. But when I click home or click kind of the site logo Monday 1st, notice there is no, why isn't my URL /home/index, right? That would follow the pattern. Call the index method in the home controller. If I use this full URL, it still works. It still loads the same page. Yet if I take out the method name, or even take out the controller name entirely, it still is loading the home index view. So how do you suppose this works? So when I click privacy, my URL /home/privacy. But when I click home, it just takes me right to the root, yet somehow seems to be loading the index view. How come this works without any controller name or any method name? You got it, Adil. So if we look back in our startup file, we have defaults. So our app's endpoint, our default root, so if no controller is specified, it automatically uses the home controller. And if no action or method is specified, the method that will get called will always be called index. So these are our defaults. You got it, Adil. Good answer. Okay, one other thing in here that's new that I want to talk about, and then we're going to take a break. Then we're going to play around with it a little bit more after we take a break. You'll notice these methods, these built-in methods, they both return an interface called an iActionResult. And Visual Studio tells us this defines a contract that represents the result of an action method. So most of the time in an ASP.NET MVC application, most of the time, so this is kind of like a parent class. So a view is a view result is a child object of action result. 99% of the time, our controller methods are going to return a view. But what else might we return in a controller instead of a view result? There are a few other kinds of action results that we might occasionally use. Can you think of anything else we might want to return besides a view? Okay, yep. Christopher, that's a good answer. It could be an alert. Yeah, we could return just a value. It's a function. Anything else we might return from a controller method instead of a view? Those are good answers. Now, Christopher, I don't think we'll be able to return an alert without a view because the alert is part of an HTML document. Yeah, Megan, we could return not only a success or failure, but maybe like an HTTP status code. Like what if the controller is returning a not found or a not authorized? What values would be for not found or not authorized that we might return? What number represents not found in HTTP? Yeah, thanks, Adil. 404 error or a 401 not authorized. And as Christopher says, we might return data just in JSON format. Maybe our controller has no front end. Maybe it's an API. So we're just going to return JSON data. So all of these things, a JSON object, an HTTP status code. All of these things are other subclasses that inherit from iActionResult. In fact, I found a good graphic the other day. Let me just see if I can find it. You can see it here as an image. So here are some of the different results. So we could get a JSON. So most of the time we're going to return a view result. But we could return a JSON result. We could return a redirect. So after, let's say, a login attempt, rather than load a view directly, we might check the user's permission and then redirect them to different places. We could return a file for download, like a zip or an executable or a PDF, or some kind of content result. And that might include an HTTP status code. Okay, so most of the time, our iAction results are going to return a view, but not 100% of the time. They could return something else. And I think we've talked about some of the use cases. Some of those things are probably familiar to you. All right, it's 2:52. So we've got our application up and running. So what I would like to do is take a quick break here. Got a few messages I should return. I'm going to go replace my empty coffee mug with a water glass. Let's come back in 10 minutes and we'll make some changes, right? We see our app is running. We want to start adding a few things and making a few changes to this kind of template application Visual Studio gave us. So I'm going to stop the recording here and we will come back in 10 minutes and do that. I imagine we should be done probably around 3:30 today. 3:30 just after. Okay, so let's come back in 10.